The James Webb Space Telescope has recently made a discovery that could reshape our understanding of life beyond Earth. For centuries, humanity has looked to the stars, asking a question as old as civilization itself. Are we truly alone in the universe? Now, with this breakthrough, we may be inching closer to a meaningful answer. The evidence found suggests potential signs of artificial activity signs that may not be natural in origin. This revelation, though still under study, opens a new chapter in our search for extraterrestrial life, giving new hope to one of the most persistent quests in human history. Our fascination with life beyond Earth is not a modern phenomenon. From ancient mythologies and sacred texts to science fiction and scientific inquiry, the idea that we might share the universe with other intelligent beings has captivated every generation. It's a deep, psychological longing for connection, perhaps. Even a fear of cosmic solitude. As we've evolved, so too has our technology, transforming stargazing dreams into data-driven missions. And now, through the lens of our most powerful space observatory, we are beginning to glimpse the faint possibility that we are not alone. In 2021, long before this potential detection, scientists using the earlier Webb Space Telescope raised a provocative question: could our instruments someday detect artificial light, man-made illumination on a distant exoplanet? That idea may have sounded like science fiction, but the team posed it in real scientific terms. They considered Proxima b, an exoplanet orbiting the closest known star to our solar system, Proxima Centauri, which lies just 4.5 light-years away. Relatively short distance in cosmic terms, Proxima b orbits within its star's habitable zone, where conditions may allow for liquid water to exist. The planet is believed to be tidally locked, meaning one side constantly faces its star while the other remains in permanent darkness, much like the Moon's relationship with Earth. Researchers speculated that an intelligent civilization on Proxima b might develop technology to generate electricity using solar panels on the day side and then redistribute that energy to the night side. A groundbreaking study, including researcher Manasvi Lingam, proposed that if large enough portions of the planet were covered with photovoltaic cells, future telescopes could detect the signature of that artificial infrastructure. Fast forward to 2024, with the technological leap represented by the James Webb Space Telescope, these ideas are no longer confined to speculation. The JWST is the most advanced observatory ever sent into space. With its enhanced sensitivity and vast observational range, it now has the capability to pick up even the faintest signals, possibly including the kind of artificial light once only imagined. There is now growing speculation that the telescope may have identified such light, or at least signs pointing in that direction. This isn't a confirmation of alien life, but it is, perhaps, a faint echo of civilization from a distant world. Before we examine the significance of this potential discovery, it's worth reflecting on the journey that brought us here. The James Webb Space Telescope's mission is part of a long-standing human effort to seek answers to the universe's most profound questions. Why are we here? What is our place in the cosmos? Is life a fluke of chemistry or a common thread woven through the fabric of the universe? Since the dawn of consciousness, we've pursued these questions through philosophy, art, religion, and now through science. Today, our tools are sharper, our reach longer, and our vision clearer than ever before. The James Webb Space Telescope is a symbol of that progress. It carries four core goals: to search for light from the first stars and galaxies formed after the Big Bang, to study how galaxies evolve over time, to understand how stars and planetary systems develop, and to look for signs of life in planetary systems beyond our own. These goals are bold, but so is the human spirit behind them. Proxima b, one of the main subjects of this cosmic exploration, is a fascinating world. It belongs to a unique class of exoplanets known as super-Earths, worlds more massive than Earth but smaller than ice giants like Uranus and Neptune. Well, we have yet to fully understand the composition and conditions of Proxima b. What we do know is compelling. The planet's mass is about 1.07 times that of Earth, and it orbits its dim, red dwarf star every 11 Earth days, a dramatically short year compared to our own 365.5-day cycle. Proxima Centauri, the star it orbits, is classified as an M-type or red dwarf star. These stars are the most common in our galaxy, though they are much dimmer than stars like our Sun. In fact, Proxima Centauri emits only 0.16% of the Sun's energy output across the electromagnetic spectrum and just 0.056% in visible light. More than 85% of its radiation is in the infrared range. Proxima b orbits very close to its star, at a distance of approximately 0.0485 astronomical units, less than 1/10 the distance between Mercury and our Sun. Despite this proximity, the planet remains within the habitable zone due to the star's low luminosity, although hints of exoplanets have appeared in scientific data as early as 1917. It wasn't until 1990 that the first confirmed exoplanet was officially recognized, revolutionizing our understanding of planetary systems. Since then, the list of discovered exoplanets has grown rapidly. By April 1, 2024, astronomers had confirmed 5,653 exoplanets across 4,161 planetary systems, including 196 systems with multiple planets. Many of these orbit M-type stars, which are difficult to observe due to their faintness, but are statistically significant due to their abundance in the galaxy. Proxima b, discovered in 2016, has drawn particular interest not just because it is the closest exoplanet to Earth, but because it might actually be capable of supporting life. It's part of the Alpha Centauri system, which includes 3 stars: Alpha Centauri b, and Proxima Centauri. Though Proxima is the smallest and faintest of the 3, it holds our attention because it hosts this potentially habitable planet, visible in the night sky. The Alpha Centauri system is among the brightest constellations, ranking just behind Sirius and Procyon. What makes Proxima b especially intriguing is its placement in the so-called Goldilocks zone, not too hot, not too cold, where conditions might be just right for life as we know it. This positioning fuels endless speculation about what might exist on its surface: oceans, atmosphere, perhaps even civilizations, if life there followed a similar evolutionary path to ours. These questions are no longer science fiction, they are real areas of scientific investigation. The James Webb Space Telescope plays a central role in this effort. Unlike its predecessors, it's capable of detecting faint infrared signals that could indicate heat distribution or even artificial lighting. If a civilization on Proxima b developed technologies similar to our solar power, heat redistribution, artificial illumination, they might leave behind traces that our instruments can now detect. The broader context of this search ties into humanity's quest for extraterrestrial intelligence, often symbolized by initiatives like the Search for Extraterrestrial Intelligence, or SETI. The idea is to look for patterns or anomalies in the electromagnetic spectrum that might suggest intelligent origin, be it through radio waves, laser pulses, or artificial lighting. It's a modern-day treasure hunt, but instead of gold or riches, we are seeking signs of life, whispers from distant stars, echoes of civilizations that may or may not still exist. With each new discovery, we stand on the edge of something extraordinary. The universe is vast, so vast that even the nearest star systems feel unimaginably far. But through science, we are reaching across that emptiness, daring to connect. Whether or not we find life on Proxima b or on any other world, this journey is valuable in itself. It reflects our desire to know, to connect, and to understand not just the cosmos, but ourselves. Perhaps the most important truth is this: every step we take into space is also a step inward, toward understanding who we are. And as the James Webb Space Telescope continues its mission, we follow in its path, watching, wondering, and hoping. Because out there, in the darkness between the stars, might lie the greatest discovery in human history.